Hello and welcome. Thanks for joining today's session, MongoDB Atlas 101. Atlas is, of course, MongoDB's cloud database as a service on AWS, Azure, and GCP. I'm your host for the session today. I'm Aaron Ballister, a senior solutions architect based in the New York City area. And I'm actually joined by something of an all-star cast of some of my favorite colleagues, other solutions architects, each of whom will be walking us through a different component of MongoDB Atlas. And so this session is a great jumping off point for seeing the vast possibilities that MongoDB Atlas brings to very high performing organizations and teams in terms of their modern application and services development. Now, to set the stage, I am going to take a step back and talk about MongoDB as a technology within the overall landscape. I know there's a lot of information on this slide. I encourage you to take a moment and digest it. But starting in the upper left-hand corner, MongoDB as a technology is only a little bit more than 10 years old at this point. And the whole concept in the late 2000 knots was that, hey, computer science had come a very long way. And distributed systems had come a very long way, and computers themselves had come a very long way. And the way we build scalable and elastic architectures and global architectures for global applications serving a global population has really come a long way. It is high time that we approach building and engineering the database from the ground up, starting now. And that's really the concept behind MongoDB. So the advantages that this approach brought resulted in very rapid exponential adoption of the MongoDB technology, which continues to this day. If we look over to the upper right-hand corner, DB Engines ranks the popularity of all the databases out there. And in a very short time, MongoDB has climbed those rankings to become the 5th most popular database in the world today. And that's not in some particular category. That's across all of the databases at all. And so what you'll notice is that it's the only one in that list that is not just a plain, vanilla, traditional, relational SQL database. Of course, it has experienced the most growth over that past decade as well. And the point gets further emphasized by the Stack Overflow developer survey, where Stack Overflow every year asks, I guess, as many developers as they can. And that number is between 65,000 and 90-some thousand across the globe. And each year that they've asked the question, for 4 years straight, MongoDB has been the most wanted database by developers. Finally, you have the Forrester Wave, the big data NoSQL category, where Forrester evaluated the 15 top vendors, including the big Goliaths, Amazon Web Services, Microsoft, Google, IBM, on 26 criteria. And they determined MongoDB to have the strongest current offering in the marketplace today. So I think this context is important because MongoDB Atlas, in addition to being a useful service and tool, it's actually become an important part of how we build modern applications today. As a service, it is the result of well over 9 years of engineering, well over 100 million that's been invested into it, and over 125 MongoDB engineers support the rapid development and support of Atlas today. It was only released 3 years ago. This was right around the time MongoDB as a company went public. And it was the first database company in over 26 years to go public at that time. What we've seen in terms of the adoption has been really even more than we expected. We've seen the market adopt MongoDB Atlas at a rate that was surprising even to us, as I said, tripling year over year. And already there are millions of MongoDB clusters in Atlas today, and tens of thousands of customers. I talked about Mongo's investment, but it wasn't only MongoDB who invested in Atlas. In fact, each of the 3 major cloud providers made significant investments into this service. And I can only speculate that it was because of the adoption and popularity kind of statistics we saw a couple of slides ago, right? They were very aware of the impact MongoDB has had as a technology out there in the landscape, and they invested accordingly. I also have to bring this up because it may seem somewhat unremarkable. It does feel to me often that most relevant softwares do have some kind of presence on each of the three major cloud providers, and they may have a tile. You may click on that tile and it may deploy a VM, and it may install some software on that VM. And MongoDB Atlas is just so much more than that. And that's what this session is going to go into depth on. It's going to be a general session, but you are going to see some very tangible stuff around each of those. And what you'll find is that it is a very deeply integrated and very fully featured, fully managed service that plugs into each of those major cloud providers in very powerful ways. And that it is truly an unparalleled, fully managed service of its kind. Especially in terms of operational database platforms, there really is many components of MongoDB Atlas that are unparalleled today. We'll see some of that. Now, these are the 6 components we're going to go into, me and my colleagues. It will help to change up the voice for each of them. And, each of us has a different style, but the final tile there, application development services, really speaks to the overall platform of MongoDB Atlas. And there are a lot of details into each of these. So today's session is sort of a broad and general session. It gives a great jumping off point, but I encourage you to dive into the deeper sessions that are more specific on some of these individual topics as well. With that, I'm going to go ahead and pass it to my colleague who is going to take us through that first component. Thank you very much.
Hello, and thank you for taking the time to listen in on my walkthrough of MongoDB Atlas's self-service and elastic capability. My name is Ethan Steininger, and I'm a solutions architect based in Washington, D.C. at MongoDB. So before we jump into MongoDB Atlas, I think it's important to give a bit of a primer on MongoDB architecture. So let's say we have our application, and within our application we have our MongoDB driver, and this all sits on its own app server. And then we have our MongoDB cluster. And so this is all in Atlas, the Atlas cloud. And so all of your reads and writes by default from the application go to the primary. And so let's say this is a write. The primary then replicates that data, those writes to the secondaries. Secondaries then send an acknowledgement to the primary, who then sends an acknowledgement to the driver saying that this write is durable. Okay. And so this is effectively how we can guarantee that all 3 nodes in the replica set have the same data. And so this is important for 2 things. One is for planned outages, and the other for unplanned outages. And so all of these nodes are their own instances of Mongo, and they're all deployed in different regions. And so if we have one of the nodes, let's say the primary, goes down, then what happens is the reads and writes from the application are constantly retried, and then the secondaries essentially undergo an election where they determine, okay, which of us is supposed to be the new primary. They determine who the primary is, and then those reads and writes that were constantly retried are then sent to that new primary. So that is effectively how we can make sure that none of those reads and writes are lost. And so that is an unplanned outage and how we guarantee high availability. Well, what happens if there's a planned outage? Well, in Atlas, it's easy. We have an automation agent that effectively steps down a primary, makes the changes to the underlying hardware. Maybe it's an OS patch, maybe it's an upgrade, maybe it's a hardware change, etc. And during that process, the replica set is self-aware, so it knows as soon as the primary goes down, hey, we need to elect a new primary. And so they, again, determine, okay, who should be the new primary, and immediately the reads and writes from the application are then routed to that new primary. And so that is how MongoDB's Atlas architecture handles planned outages for what we call rolling updates to make sure that there is no change to your application query. All right, now that we have a primer on MongoDB Atlas architectural best practices, let's go ahead and create a cluster. Here we're presented with the option of selecting the cloud vendor that we want to deploy the cluster in. We'll just stick to AWS for now. And here we have the option of selecting the individual nodes by which we want the regions to be, or the individual nodes we want to deploy in each region. And again, we'll just stick to the default setting of US East 1. Note, this is not covered, or this is not available during a full region outage. So in other words, if US East 1 goes down, then we will have to, then our application, our database will effectively go down. And so that's where we'll have to make sure that we have coverage in a full region outage, distributing our nodes across multiple regions. But again, we'll just stick to the default setting. And then finally, we have the ability of selecting an analytics node to deploy in our replica set. And this is effectively allowing us to send our very compute analytic workloads to a non-voting secondary in our replica set so that no bandwidth is shared in the production replica set of nodes that have the potential of becoming primaries. And if you recall from the diagram, you'll remember that within the 3-node replica set, 2 of those secondaries can become primaries within an election. Analytics nodes cannot. And then here we have the option of selecting the tier of the nodes in our replica set. Here I have an M30 by default. And within that, I have these configurations. I can provision my storage. I can auto scale my clusters within a certain range. And what this means is basically the Atlas automation agent will determine, based off of historical trends to my database, it'll say, hey, scale up or scale down based off of the threshold of traffic that is being sent to my database. And so that is, again, going back to the diagram, does so in a rolling fashion so that the architecture is always on. And then similarly for the disk space, we can provision our IOPS. And then if we go down below, we can also select the different MongoDB versions that we want to deploy as. And so I'm not going to create a cluster right now since that's already created, but all of these are options that you can configure when the cluster is already live in production. And again, going back to that diagram, these changes that are made in a cluster that is already provisioned are these changes can be made in a rolling fashion. So again, not impacting the architecture at all. And so if I were, for example, to change this from an M10 to an M20, and I'll disable cluster tiering, I'll apply the changes, and these changes are being deployed using this automation agent here. And so what's happening is it's stepping down the primary, making the changes to the primary, and then stepping it up in a rolling fashion so that there is always a primary available. And then also I have the ability of pausing the cluster here if I only want to pay for storage and not compute. And then finally, we have the availability, the ability to make all of the changes that I just showed you with the APIs that we have available. So if you're a CI/CD shop, if you're using Terraform, or if you're just building your own pipeline, then you can leverage the APIs that are essentially all of the UI options that I just showed you are using the API endpoints behind the scenes. So if I were to create a cluster here and then refresh my page, I can see that sample 2 is being created. And if I go back to the actual script, I can see what's happening is I'm sending a post to this endpoint here. And within the post, I have this payload that basically signifies, hey, I want to create a cluster with this name, this disk size, this provider, this cluster, etc. And I can do so here. And then alternatively, I have a number of other endpoints, and this is not fully comprehensive, but I can pause, resume, create a backup, restore the backup, etc., all from within the API. So allowing you to programmatically spin up clusters, deploy within a CI/CD pipeline, etc., so that you're fully automated in your scale up and scale down. So that's scaling up and scaling down from within the Atlas UI or the API, and that's it. And so I'll pass things over to my colleague for the next session. Thank you.
My name is John Muzak, one of MongoDB's solutions architects based out of Philadelphia, and I'm going to be guiding you through the global and cloud agnostic features that are a part of MongoDB Atlas. MongoDB Atlas enables you to create and manage your database on all three major public cloud providers, namely AWS, Microsoft Azure, and Google Cloud. Atlas supports a number of regions in each of these cloud environments, including over 20 AWS regions, 35 Azure regions, and 24 Google Cloud regions. Let's take a look at how easily you can get started building a cluster in these cloud environments today. This is the cluster creation and configuration page inside MongoDB Atlas. You start by selecting the cloud provider where you want your MongoDB cluster to reside. As I just mentioned, we support numerous regions across all three cloud providers so that you can use the one that is the best fit for your application. Additionally, because MongoDB runs the same way across each cloud provider, you can easily migrate your database cluster between different providers without any changes being required should the need arise in the future. You can also configure your cluster to take advantage of multiple regions for increased fault tolerance and high availability. Once you enable multi-region options, you can add additional regions beyond what you originally selected for the specified cloud provider. With this approach, if there is an outage in the region where one of your cluster's nodes resides, the nodes in the other regions will be able to recover and assume all read and write operations for the cluster. MongoDB Atlas also allows you to add read-only nodes for the cluster. These nodes can be added to support location-specific low-latency reads for users in that region. Because they're read-only, they are ineligible to be selected as a new primary node during elections in the case of failover. With MongoDB Atlas, we can also configure our cluster to support location-aware read and write operations for application instances that are globally distributed. This configuration can be especially useful when you need location-aware data storage to comply with regulatory requirements or meet certain latency and performance goals. By enabling global writes, we can define single or multi-region zones that support write and read operations from a geographical local shard. Here, I'm using a basic zoning template to create 3 zones, one for Americas, one for EMEA, and one for Asia-Pac. This configuration enables us to start storing data only in its specified region. Zones can also be configured to support low latency local reads by placing read-only nodes in the preferred region of every other zone in the cluster. For example, if I have a zone that encompasses Europe, the Middle East, and Africa, I can write data to a primary node in that zone, but have it be available on read-only nodes in the Americas and Asia Pacific zones for quick access to users in those zones. Depending on how many zones you configure, you may want to provide a broader or more specific name for each zone. You can rename each zone as part of that zone's configuration as well by changing the zone name under additional options. And of course, you can configure the regions used for each zone, distributing the replica set's nodes across them just as we did before. If, for example, I don't want all 3 of my nodes in the Frankfurt region, I can add additional European zone regions such as Paris or even Milan and distribute my nodes across them for even more fault tolerance and high availability inside that zone as well. With a global zone cluster, you can move a record from one zone to another just by changing the value of the location field. This can be extremely useful when you want to reduce the read and write latency for your application or restrict data from being stored in certain geographical areas. As an example, we have a customers collection in a global zone database. If we look at one particular document inside this database, we can see that we have a customer called David Bellini, whose location is listed as CA for Central America. If we look for this document in different zones, we'll notice that we only find it in the one shard that's listed as the Americas zone. If I also look for that document in the EMEA zone, I won't be able to find it because it's not there due to the value of the location field being CA. If, however, we decide that we want to update the location field for that customer from CA to something like IT for Italy, and then we go back to the America zone to look for the customer, we'll find that it's no longer located in the America zone. Going back to the EMEA zone, we will now see that that same customer moved from the America zone to the EMEA zone with just the update to the location field. Therefore, by changing that one value, we're able to abide by any regulatory requirements that require us to keep data in a specific geographical region, or we're also able to meet certain low latency read and write requirements for performance and benchmarks. MongoDB Atlas also provides a live migration tool to easily move an existing MongoDB cluster into Atlas. Provide the connectivity information to the existing cluster inside this window in MongoDB Atlas, and Atlas will handle importing your data for you. During a live migration, the cluster is kept in sync with the original source cluster until you explicitly choose to cut your applications over to the Atlas cluster, making sure that you are in control of when that cutover happens. Thank you. And now I'm going to pass it along to one of my colleagues who's going to share the next topic with you.
Thanks, John. Back to Aaron here. And I'm just going to tack on to the end of John's presentation an exciting announcement, which is the general availability of multi-cloud clusters in MongoDB Atlas today. This is unique and unparalleled. Once again, an example of MongoDB breaking the mold and exhibiting that cloud leadership. And it enables organizations and teams to take advantage of best of breed technology across multiple clouds as part of a multi-cloud strategy. It allows for seamless migration from one provider to another. It improves high availability with cross-cloud redundancy. And it extends reach, right? Each cloud provider makes certain regions available. And with multi-cloud clusters, any of the regions from any of the three cloud providers are available to choose from when building out your cluster topology. So this can extend reach in terms of your data distribution policies. And we're very excited about this. Many customers have been asking for this for many years. It's many years in the making. It's not an easy feature to release. And I am certain that our customers are going to be doing some very exciting stuff with this. With that, I'm going to proceed to our next section, enterprise-grade security and SLAs. Firstly, MongoDB Atlas has been issued certifications from all of the relevant third-party governing international compliance standards, and it offers a 99.995% availability SLA. So that means that MongoDB guarantees that these environments that you're provisioning, these MongoDB environments that you run your applications off of, et cetera, will be up and running and available for your use at least 99.995% of the time. Our actual experiences on that are much, much higher, but that is the guarantee, and that SLA is relevant. It is one of the important reasons that organizations and teams choose Atlas to de-risk their applications and projects, and to take that liability away from their own teams, basically the liability of having to keep the lights on, and allows those teams to focus on the differentiating features of their application, right? Now, MongoDB as a technology has been offering enterprise-grade security since well before Atlas existed. And so it may come as no surprise that Atlas implements all of the MongoDB security best practices. And in fact, it does so by default. So there is a base level of security that is going to be implemented on any and all MongoDB clusters. It will include authentication and authorization. It'll include encryption and flight for all traffic, and also encryption at rest for all data that's being persisted. It is worth noting that the customer, or you yourselves, are both legally and technically the data controller. So you have full control over all of the network access controls and all of the data access controls. What we're going to do is go through each of these categories: authentication, authorization, auditing, encryption. And what we'll see is that these categories are not just checkboxes. Each one of them is quite extensive and Many offer many different options to support different types of organizations. The other thing we'll see is the granularity of these controls kind of throughout as well. If I take role-based access controls as an example, I've seen cloud services out there that claim support of that, and they have two roles: admin and read-only, right? And that really doesn't pass my personal sniff test. And I have a couple of distinctions that I want to make before we kind of dive into this. One is around authentication at the network layer, which really focuses around what typically firewalls address and other network configuration tools address, which is which machines or IP addresses or IP ranges or private networks are allowed to even enter into the network to even ask permission from the database for access. Right? So that's where the network controls are going to come in, and we're going to see a couple of ways that you can configure that, versus database and data access controls, which are your typical controls around username and password when authenticating against the database. It also has to do with what actions that particular user who is authenticated against the database is allowed to perform, and on which data resources are they allowed to perform those actions, right? So that's the authorization part of that. The second distinction I want to make is the difference between authentication and authorization, users and roles for Atlas at the Atlas layer versus authentication and authorization, users and roles at the MongoDB cluster level. So these are the MongoDB environments that your applications run off of. And those are distinct, right? So they are in fact physically and logically separate, right? And so Atlas itself is what is known as a dual control system. And so it is supporting segregation of duties, where you have the application code which interfaces with the database. That is one set of controls, probably led by the developer team who's writing that code and interfacing with the database. And so what you would have is separate people who are going to be the Atlas users who manage those MongoDB environments, right? And so they're going to be in charge of setting up the network access controls and the database access controls and things like that. And this segregation of duty is an important security concept that you'll see throughout Atlas, supported in many different ways. That kind of dual control and segregation of duties, supports the idea that no single user should be able to do something nefarious on their own, right? If they were going to do something nefarious, if they were going to grant access to, let's say, themselves to access data, with proper segregation of duties, they would have to collude. They would actually have to convince one or if you're doing it right, many other coworkers, colleagues to collude with them, right? And so this is an important principle because most likely the honest coworkers are going to raise flags when that happens, and it's a very strong deterrent and an important concept in this kind of a securitization discussion. Okay, so we're going to see those kinds of things throughout. There are additional dual controls on the Atlas side, specifically around how you do authentication with dual factor authentication, for example. You have some optional choices here too, like encryption at rest, where you manage your own keys. So I said every MongoDB cluster in MongoDB Atlas is encrypted at rest and has all persisted data encrypted. But you can also bring your own key. And so again, that would be a separate key management service, which is logically and physically separate, managed by a different team and different personnel. And they would manage the encryption keys that the MongoDB storage engine uses for encrypting data. So that means they manage rotating those keys, they manage rescinding those keys or removing or destroying them if we want to basically make all of that data unreadable. And so that's yet another one of these dual controls that reinforces segregation of duties. Let's jump in very quickly. Before we do that, I do want to give a high-level view on how resources get organized into Atlas. So MongoDB environments are organized within projects, right? So you can have many MongoDB clusters or environments within a given project. And then projects fall under organizations. Projects consolidate access management. That includes network controls. It includes data access controls and users and roles. It includes whether you want to integrate with an LDAP interface for a centralized Active Directory or Octo or other system that supports that LDAP interface. It's where you configure your encryption, your encrypted storage engine configurations. It's where you're going to configure auditing. And so you can do that once in a consolidated way, and any and all of the MongoDB clusters that fall into that project will follow those same rules. Of course, you can have as many projects as you want, right? And so this gives you a great balance of being able to have lots of different environments that have different access rules, but also being able to consolidate ones that have similar rules. Now, at the organization level, right, each project falls into an organization, and organizations consolidate Atlas users and their privileges, as well as billing and billing settings. Right. We're also going to see how you can define teams of Atlas users within an Atlas organization, and Atlas users in a team will share the same project access. So another great way to kind of consolidate that management. It really fits very well with the way modern organizations and teams build and develop modern software. Okay, so enough of that primer. Let's dig into Atlas itself. So right here, I'm under the organization settings. And one of the first things you're going to do when you create a brand new Atlas account is you're going to create an organization, and you're going to give it a name, and you're going to be assigned a unique identifier. And then there are organization level settings that you can set up, right? So one of those would be to require two-factor authentication, for example, that dual control, which means that another system will also have to corroborate that this user is authenticated. Right, so common implementations of this would be an application, like Google Authenticator is an application that does this. You can also use just simple SMS text messages, right? I'm sure everybody's had that before using one system or another. You have to get a text message that gives you a code, and then you have to enter the code, and that's your dual factor authentication. Another one is a phone call, same idea. Some organizations prefer to use different authenticators for authenticating against MongoDB Atlas. And so you can set up federated login for those different systems to authenticate against Atlas. It's beyond the scope of today's discussion, but there's great documentation on this, and I encourage you to look into that. This is especially relevant for large and complex organizations that have existing authentication providers that they work with. Now, the other part that we talked about was access management. And this is really users and roles, which is at the organization level. These are the Atlas users and roles, right? As opposed to the actual MongoDB clusters and those users and roles. So for here we have the access manager where we can invite users, for example. So we simply enter their email address and give them permissions or access roles. So what you'll see here is that these are for the Atlas users, and you can see segregation of duties across these different types of roles with different privileges. So an organization owner might be able to invite users and modify their permissions and roles. But an organization project creator can only really create projects. They can't do anything with billing, and they can't add new users and change their permissions. Similarly, a billing admin is allowed to change the billing settings, but they're not able to create projects or add users and change the privileges for users. So we see this segregation of duties here, and we can see how when we have different users, we can separate out their different functions appropriately. And this really is a matter, is different for every organization, right? Typically, the more complex the organization and the more sensitive the systems that they're supporting are, then the greater the adherence to segregation of duties needs to be. And so you can really find that happy medium here. So as you see that we just invited that user received an invite in their email. And so they would have to accept the invite in the email, and then they would have credentials that they can then use to log into MongoDB Atlas here under this organization. Great. So the user I'm currently using is right here. And as you'll see, this user is the organization owner, so I'm able to actually make changes to user roles and permissions here. So I could edit the permissions, grant additional privileges, and I can also remove users and remove permissions as well. So that's how we do users at the Atlas level. And as far as creating teams go, we could simply create a new team and we give it a name, call it the team G, and we're going to invite certain users to that team. There we go. We have a team. Sorry, I guess I don't have that user doesn't exist. But you get the idea. We add users to a team, and we then can give that team access to specific projects. Now, all of the things we're doing here in the Atlas interface, we're doing it through the user interface, right? But we can also do all of these things through API commands. And there are lots of reasons organizations like to do that kind of thing. Sometimes they're doing a lot of infrastructure as code. Sometimes they are doing these kinds of operations from a more centralized position, and so they want to be able to do it that way. Sometimes they are doing it in a more programmatic way as well. So they just simply want to be able to automate some of these functions. And so they're writing, scripts to do so. And those APIs will go ahead and perform these functions and actions. So that's where you can create API keys. And it's the same idea where we create an API key, we're going to give it a description, and we're going to give it a role. So we might create an API key that is allowed to just get information about an organization. They're not really allowed to modify anything about the organization, but they can just get information. Great. We would just maybe make a description here, get info on org. And we click next, and then we're going to get to a secret here. And we're now responsible for maintaining this secret. As soon as we click done, we'll never be able to retrieve this secret for that API key again. And so, we're going to have to make sure we safeguard that. Now, I should mention that Atlas also supports HashiCorp Vault, which is a tool for doing that in a programmatic way. And it allows DevOps teams to generate these kinds of ephemeral database users and programmatic API keys centrally, allows developers to focus on building applications and things. And so that is also supported as well. Again, we're not going to go into depth on this, but it is documented, and I encourage you to look into that if that's of interest and if you use HashiCorp Vault. Okay, great. So that really covers Atlas users and the roles that they're granted and how to kind of control that, right? Next, we want to go into projects, okay? And so these are the projects within that organization. We're going to make a new project, let's say, and we'll call it Project G. And there we go. And we're going to assign some users to this project and give them project level permissions and controls. So we can say that this user is a project owner. So that means they're able to invite other users and give other users permissions and change those permissions. We could also have a project data access admin who's able to access data, but can't change or alter it. Maybe there's a read-write role here for being able to access data and write data to for the clusters that are in this project as well, right? So we create this project and we assign team members to it, or we could assign a team explicitly to this project, right? And then here we go. We now have that project. As you see, Project G, which is in the organization that we were just in. And this is a familiar screen that you saw from our previous sections that we covered, right? So each project, you can have as many as you want, and each project will have a dedicated VPC. And that's important, of course, for network controls and giving you full control of your network controls. One thing I will point out is we're going to go ahead and configure a bunch of security controls here. And we're going to actually do that before a MongoDB environment even exists. This is an advantage for several reasons. One, as you know, Atlas is a consumption-based service, right? So right now, we're not paying for anything. We don't have any clusters or environments in here. But once we do provision environments, then we're paying for those, right? And the larger the environment, the more it's going to cost and things like that. It's consumption-based. And so this allows us to do all of this security and network controls and configuration before any cluster even exists. The other reason that this is very important is that there are a lot of systems where the securitization of that system needs to be end to end. In other words, it's not just good enough that the system is currently secure. It needs to have always been secure as well. And so this enables you to do that. And we're going to go through this process right now. So we're going to start with the network access controls. This is really that first line of defense. As I said, it governs the network layer and allows which machines, which IP addresses or IP ranges, and which private networks are going to be able to access this environment at all in the first place, right? To even ask the database for permission or access. So when we go to network access, we have a few different options here. And I think before we do it, let's do a quick primer on each. The first is IP whitelisting, as we call it. So as we said, we have a dedicated VPC per project, and the network is completely closed off to the outside world. So nobody is allowed to access this until you explicitly say so. So you can permit an IP address one at a time or a range of IP addresses to allow inbound network traffic from those. Those IP addresses would then have to ask for permission from the database and authenticate against the database to do so. We, of course, have encryption in flight for all traffic, as we talked about. You would still have username and passwords required for the data access layer. And we have encryption of data at rest on all of the data that's being stored as well. Now, another option is also VPC peering, and this is where you would peer the VPC that contains your Atlas clusters with, for example, the VPCs containing your application servers. And so that is done over a private network, and so you have that peering connection. The third option here is private endpoints, as we call them. AWS calls this private link, and Azure calls it private link as well, but it's two words. So these have become very popular, and for these two providers are currently fully supported in Atlas. For the AWS, after about 8 months after AWS announced private link as GA, it was fully supported in Atlas, and about the same thing happened with Microsoft Azure. So keep that in mind. There are times where there isn't parity across the cloud providers, and generally that is really temporary. There might be reasons because sometimes the cloud providers actually make these services available first, right? In the case of private link, that was the case. AWS made it available first. MongoDB Atlas supported it approximately 8 months later, and then the same thing happened with Azure. But in general, Atlas aims to have parity across all of those cloud providers. So if GCP supports private link, I would expect that we would also support it there as well. So there's some differences with private link. They're one way, they're unidirectional. So they are initiated from your networks rather than Atlas being able to initiate the connection. And they are transitive to other peered networks. So there's some other advantages that those cloud provider private links offer, and they're supported in Atlas. So let's go in and do some configuring along each of those three categories of network controls. The first one being IP whitelists. we can just explicitly enter an IP address or IP range right here, and that would permit inbound connection. I'm going to go ahead and permit my personal workstation to be able to access this just by clicking that button. Kind of a handy, fast way to be able to get that access from my local workstation. Now, I can also make this temporary. And this is very useful. This follows that principle of least privileges, an important security concept. So we can just make this credential essentially expire after 6 hours or a day or a week. That principle of least privilege says, this user is going to need to log into, let's say, the MongoDB shell for one of the clusters that's in this project and do some task. Well, after they're done with that task, we can go ahead and rescind this IP whitelist entry. So I'm going to go ahead and do that. I'm going to leave it as a temporary one for now, and I'll confirm that. Next is peering. Peering is quite straightforward. We choose the cloud provider of choice. We're going to basically provide the identifying information for the project and the VPC that we're going to peer with. We're going to specify the Atlas CIDR block here. So this is actually important. CIDR blocks cannot overlap with the CIDR block of the VPC in the cloud provider. So that is at least a limitation on the AWS side. If we go here, you'll see that this CIDR block in your AWS VPC cannot overlap with the Atlas CIDR block. And this Atlas CIDR block cannot be changed once you have your environments provisioned in Atlas. So, if you're working with AWS and you're planning to use VPC peering, make sure you have these things figured out before you start provisioning those environments, certainly at least production environments and things as well. Great. So basically we enter that information and then we'll click next and we'll click done through this. I'm not actually going to do it, but for the AWS example, you would then go to the AWS management console, go to where VPCs are managed, and you would find an inbound request, peering request. And you would have to accept that on the AWS side. I say you, but really that's probably your network administrators who manage the AWS VPCs or network controls, right, within your teams or organizations. But they would have to accept that peering connection. And I will just caution you, sometimes that connection takes a little bit of time. There's some automation on both sides, on the AWS or the cloud provider side, and as well on the Atlas side. So it can take a little bit of time. If you're ever experiencing a little delay on that, don't be too concerned about it. Wait it out and it should be fine. Okay, and then finally, you can configure private endpoints. It's a similar kind of process. We choose the cloud provider, we choose the region. It's a little bit of a different wizard for each cloud provider based on how those cloud providers implement these features and functionality. We're going to provide the identifying information, and we're going to get a command that can be issued from, in this case, the AWS side of things, in order to initiate a private link or private endpoint. Okay, great. So that about covers the network access controls. We went ahead and did create an IP whitelist. One thing I should also mention that these are not mutually exclusive. It's not choosing this or that or that. They're actually, they're independent, right? And it's not uncommon to have your application servers in a VNet or VPC, and then you have that peered with your Atlas environment so that there's a private peering connection there. But then for maybe a developer or administrator who needs to go in and access the MongoDB shell from their local workstation, you might just use an IP whitelist for that. And again, use this temporary credential to make that expire after a certain amount of time when that task has been completed. Right, so those are very common to what we see out there in terms of organizations and teams using this. Great. Let's move on to database access controls. So this is where we're going to configure for all of the MongoDB clusters in this project, the database users and roles and privileges that those users will have, and on which resources they will have those privileges. So I'm starting out here with users, and it's very straightforward to add a new user. We can simply use the most basic kind of method for authentication, which is what's called SCRAM, or Salted Challenge and Response Authentication Mechanism. This is a username and password. Do you know the username, and the password is the challenge, and the response has to be the correct response. And so it's that simple. We either provide a password or auto-generate a secure password, and then we would securely transfer this credential to whichever user is going to use this, or if that was ourselves, we would just simply start to use it. We can again make this user temporary and make their credential expire after a period of time. We can restrict their access to a specific cluster or data lake. We don't have any clusters right now, but this is kind of a way that we can still have granular controls, even though database access is being consolidated at the project layer for all clusters in the project. We can kind of override that here to say, actually, this user only has this privilege on this cluster or this data lake. Now, another option to take instead of username and password or SCRAM authentication is certificates, known as X509 certificates. This is a more robust and rigorous approach to authentication, mainly because X509 certificates are easier to securely transfer, right? It's easier to securely transfer a file than it is to transfer a username and password. For example, a username and password is fairly easy to screenshot. It's even easy to memorize, and it can be fairly easy to overhear. For example, you could actually just overhear that credential, whereas a certificate is a pretty big encrypted-looking file, and it's not easy to screenshot. It's not easy to overhear. You can't memorize it. Things like that. So, X509 certificates are definitely a more rigorous approach to authentication. Other option here is AWS IAM, currently supported, right? As I said, I would expect this to also be supported for the other cloud providers in time, currently just for AWS. But this would basically mean that when your application wants to authenticate against the database, it would use AWS IAM users to do so. Great, so we've got our user, we've got a password for them, we add the user, and there they are. Okay, now one of the things that we did with that is we actually assigned a role, and we used one of the built-in roles. So we use this read and write to any database. And these are kind of the common roles that are used, that are built in, and you can grant specific privileges to be more specific if you'd like. But what you can also do is construct custom roles. And these custom roles are very granular. I'm going to give it a name, custom role 1. And what you'll see here is how specific we can get around these different actions that we're going to grant to this role, or users who belong to this role. So, for example, I could say, users with this role can only query and they can only update records. They're not allowed to actually insert new records, and they're not allowed to delete records, but I am going to also let this role create indexes, for example. You can see you have really granular and precise control over precisely which actions are allowed and on which resources. So right now, we're allowed to query and update and create indexes on any database in any collection, right? But we can get more specific here, and we could say that this is just for the collections in let's call it Aaron's database. So any of the collections in Aaron's database are allowed. Okay, so we just set that up, and we've granted those actions for this role for any of the collections in Aaron's database. But there might be other databases like Sally's database, and Maybe for Sally's database, we're only going to grant these actions for a specific collection. Sally's favorite collection is the only collection where this role has these privileges. And we just created this custom role. We can see it at a glance very easily. We can see what the privilege is, and we could see which resources that privilege is granted on, right? And then we could assign users to that role. So we could give this user one of those custom roles down here as well. Very good. So that covers our database access controls. Finally, I'm going to go into some advanced options, which is where we will configure LDAP authentication and authorization. Many organizations will use a centralized directory of some kind for managing their users and roles. And we can simply configure our LDAP authentication and LDAP authorization. I won't have time to do it today, but this is well documented. And you can actually just do authentication, or you can do authentication and authorization. So keep that in mind. Authentication would say we're just going to use the users in that central directory system for authenticating against them, their username and password credentials, or whatever the authentication mechanism is. If we also want to use LDAP for authorization, it means that we're going to also take the groups and roles, or the groups that are in that centralized directory, and we're going to map those to specific roles over where we defined those roles and where we create users under database access. So keep that in mind. Those are common options used, especially in enterprises and things like that. Next here is where we will also configure encryption at rest. We're going to specify which key management service provider from which cloud provider. And, it's a little bit of a different wizard once again for each cloud provider, but basically you're going to provide the identifying information around which Azure Key Vault in this case, which subscription ID, which resource group name, and the Key Vault name. And then that is the system that will manage the encryption keys for MongoDB's encrypted storage engine on all of the clusters in this project. Fairly straightforward to do all of that stuff. And then finally, here's also where we can set up X509 certificates, and we will provide an actual certificate authority for them as well. One that I skipped was database auditing, which again, I just want to highlight the high granularity that we have here. We can set up auditing for Scram users or external users or both, also database roles and LDAP groups. And we can audit very specific functions, right? We can say exactly which actions we want to audit, right? And this is useful. I will mention that this auditing capability in a lot of self-managed MongoDB systems can be an overhead because it can add a lot of rights. If you were auditing every single insert, for example, then that turns into 2 writes on the database, and so it's overhead. This is implemented in a way that's very non-interfering with your underlying MongoDB clusters, and that's very useful as well. And then you're able to simply download the audit logs from this as well. Great, so I think I have a couple of quick points to make before we wrap up. Atlas encryption at rest follows all these best practices, which is that your environments are on dedicated clusters. They have dedicated compute. They're in a dedicated network, VNet or VPC, and it can be encrypted by your cloud provider or bring your own key, right? So that sums up enterprise-grade security and SLAs. Thanks so much, and on to the next section.
Hello, I am Nadia Yameen, one of your solutions architects based out of New York, and I am going to be guiding you through comprehensive monitoring within MongoDB Atlas. Atlas provides you deep visibility into your performance of your cluster as well as your database operations by allowing you to view over 100 plus metrics for proactive monitoring and alerting. Within my Atlas cluster, I can see my fine-grained monitoring metrics and alerting by selecting metrics. Here, I can view KPIs for replica sets, sharded clusters, as well as MongoDB processes. Notice that the granularity level is at 1 hour, which will be correlated to our retention period of 63 days. The length of retention depends on the granularity level. If you have 1 minute granularity, the data will be stored for 40 hours. For 5-minute granularity, 48 hours as well. And then if you want the 1 day granularity, you have the option to store the data forever. Some of the KPIs I want to highlight are the 3 we have selected here, which is the scan and order, which takes a look at the average rate per second queries return sorted results without using an index. We have our memory consumption as well as the operation execution times. Notice that we have the data that's stored is going to be for each of the members of the replica set. Towards the bottom, you can see here we have additional KPIs that we can include, such as disk IOPS, latency, system CPU, as well as a host of other KPIs and metrics. This really gives you an interesting purview into the performance of your hardware, as well as some custom MongoDB metrics. Now, as we take a look at the data that we have stored here, it's stored at a granularity level. Now, if we want to transition and take a look at real-time KPIs, I can go ahead and select real-time here. This will monitor and display current network traffic, database operations, as well as hardware statistics about your hosts. Some of the things I want to highlight here is on the right-hand side, we have our list of hottest collections. This is actually taking a look at the collections with the most operation executed. And then also, we're in real time capturing statistics about operations, query execution time, reads and writes, as well as taking into account the slowest operations as noted by the right-hand side. With this, I have a real-time view into the health of my cluster, as well as the health of some of the operations and collections within my database. Now, if I wanted to go ahead and expand on one of these collections and take a look at how indexing can improve the performance of the reads, I can go ahead and select what's called Performance Advisor. With Performance Advisor, it gives you index suggestions based on slow running operations. You have the ability to see the average number of index or scanned documents returned that would be improved as a result of implementing this index. Here, notice that we have our namespace metrics.employees, and within this namespace, the Performance Advisor is suggesting that we create an index on the attribute companies.companyname as well as first name. And notice the first attribute companies.companyname, it's saying that to sort it in ascending order and first name by descending order. And what we're going to see is a over 200% performance impact as it relates to improvement on the queries approved the queries that are going to be leveraging this index. And some of the sample queries improved by this index include a find on the company name attribute as well as a sort on first name. This is really interesting because when we take a look at the target querying, this is taking a look at how many documents are scanned or impacted by this particular index as a result of this query executing. Performance Advisor is very powerful when we start talking about performance optimization and tuning within MongoDB. The other KPIs to also take a look at is the query profiler. The profiler is actually a component which allows you to see and view some of the commands and essentially resources that are consumed. So this is intended to diagnose and monitor performance issues, expose slow running queries, as well as collect data from the MongoStat or MongoDB processes. And you have the ability to drill down into the specific namespace. Now here, if I want to go ahead and drill down into my sample.airbnb listings and reviews namespace, I can see all of the commands and their related execution times. Now here I have command that's actually doing executing an insert, I believe. And notice here the query execution time, the documents returned, and keys examined. So if you remember, we don't necessarily have an index on this namespace at the moment. So therefore, the index keys examined would result into 0. This is a really good way to also add to the performance and optimization of your queries. So here it's going to take a look at some of the slower running queries and help you diagnose some of the query performance issues. The last thing we want to go over is going to be the alert settings within MongoDB. Now you have the ability to alert on any metrics as well as any component within MongoDB. And if I want to go ahead and edit one of these alerts, here we're targeting our host, and if the host system CPU is above 50%, we're actually stating to send a alert to the project owner. And this is applicable on any host within the replica set. So you can see here the number of conditions and metrics that we're capturing already, and due to any violations, we will go ahead and receive an alert. This is a very good way to make sure that the alerts are sent to the appropriate teams so that they can take any further action. Now, with the deep visibility into the KPIs, you're able to not only take action, but also diagnose any performance issues problem. I want to thank you, and I'm going to pass this along to one of my colleagues who's going to share the next topic with you.
Hello, folks. My name is Winston Vargo. I'm a MongoDB solutions architect based in the beautiful city of New York City. And I'm here today to guide you through manage backups. So a lot of people probably know that MongoDB and MongoDB Atlas replicate their data by default. But what happens if a database is dropped? Or in this case, what happens if a commit causes data to be incorrect? Well, enter your best friend backup. I'm going to initiate that right now and talk as that's going on. So managed backups are a key part of MongoDB Atlas. The underlying idea is cloud provider snapshots. So as we know, MongoDB Atlas can be deployed in AWS, Azure, or GCP, and our MongoDB Atlas backup and restore functionality uses the underlying disk provider snapshot capabilities, but abstracts the processes around actually taking those snapshots and restoring from a snapshot. So some of the features that we provide for you is a customizable snapshot schedule and retention. We allow you to be sure that your backups are stored in the same cloud region and same cloud provider as your managed databases. So for things like CCPA and GDPR, that's handled for you. And it goes beyond that as well. If you are taking advantage of MongoDB's WireTiger encryption, for instance, we still allow you to use the backup snapshot capability and furthermore allow you to restore that data as well. These snapshot restores are obviously very quickly, and we take advantage of the cutting edge technology to make sure that that occurs as fast as possible. And notably, the cloud provider backup snapshot capabilities allow you to restore your clusters, whether these clusters are replica sets or more complex sharded clusters. And that's not all. Now, MongoDB Atlas has a new-ish feature, which is continuous cloud backups. So some people might have talked to you in the past about how MongoDB uses an oplog to replicate data from a primary to secondary node. Now, with MongoDB Atlas, we are backing up the oplog such that within a configured window of time, you are able to restore your cluster to a point in time, as granular as the minute. And for those who are a little bit more familiar with MongoDB, we also allow you to restore to a specific oplog timestamp. Let's see some of this in action. So just to level set, this is my Vargo project, and I'm querying against my WinVargo cluster. You can see that I'm currently in the process of restoring from backup based on our earlier query. So let's drill in here. Here is the screen that I briefly showed you before, which shows a list of all of these snapshots that I've taken. Now, I have some snapshots that are hourly, some that are daily, some that are on demand. And if I scroll a little bit farther, I also have weekly and monthly snapshots. When I actually want to restore these snapshots, all I have to do is click on this restore button, and I'm allowed to choose a target cluster for my restore. So notice that not only can I restore to the source cluster, but I can also restore to another cluster in my project. And that's great for use cases where, for instance, there's pre-prod clusters that require prod data in order for tests to be effective. If you don't want to use this automation to restore your backups to an existing cluster in MongoDB, of course, you can always click on this download button, and assuming that you are downloading from a whitelisted IP address, we give you the ability to actually download that data if you want to keep it on premise or really do whatever with it. Here, I show you a restore history. So you see that right now my existing restore is being prepared. I initiated a manual download before, so if I go to this link, I can download that same data. And it really gives you an audit log of the backups and restores that you've taken in the past. And of course, this is all configurable. So in this case, I have an hourly snapshot every 6 hours that's retained for 2 days, for instance. Well, maybe I want to take a hourly snapshot every hour, but only retain it for a single day. So based on your business requirements, you can configure your point in time and your backup policy frequency to make sure that you get the best performance and the best safety for your data for the lowest cost. And finally here, I'll show you that there's this point in time restore policy. So in my case, any restore that I want for the last 2 days or 48 hours, I can actually roll back to a individual minute to make sure that my data is as valid as I want it to be. I'll end here showing my snapshots. So let's take a look at the status of the backup that I've taken and /restored. So you see, as we expect, now the data looks more valid. It's in the form that I've backed it up to, and my business can continue as usual. So thank you everybody for your time, and I'm sure you're excited to hear my colleague discuss some more features of MongoDB Atlas. Have a great day.
Aaron Ballister here again, and we've saved the best for last. I'm going to finish out our session with the last category, application development services, which admittedly is a bit of a catch-all, right? And it really speaks to the broader platform around your MongoDB environments in MongoDB Atlas. So obviously there's only so much you can do when you're packaging software and then supporting customers running it in their environments. And the cloud service model really opens that up and makes so much more available, allows Mongo to offer so much more to your organizations and teams. That includes the data foundation itself. These are data technologies that are focused on different functionalities, right? So MongoDB itself for your high performance, high scalability, operational persistence layer for analytics and operational data, right? But search is a completely different technology from database technology, right? Well, it's implemented. Atlas Search is fully implemented. It is incredibly powerful and gives you access and is fully integrated so that you can just run aggregation commands that include this rich search capability as well. Also, data lake, right? Not all of the data needs to be so performant all the time. And a lot of the data can become very voluminous, right? There's a lot of it. Historical data that becomes cold after a certain amount of time. Well, maybe we can put that into Atlas Data Lake, and we still can query it. We still run the same queries that we were using before. In fact, you can even federate it. So you have a common endpoint across your MongoDB cluster and your Atlas Data Lake. You can run those queries against that endpoint, and you don't even have to handle the logic for whether the data is here or there. Really great stuff. Then you've got developer services. I'll start with triggers and functions. Very popular and common for modern and cloud application and architectures especially, right? So this is a way to just put watchers to essentially watch specific data. To say, let's say for this collection, I want to watch, and if any of these records are updated, I want that to trigger this function to run. The function is run serverlessly, and what that function does, there's a lot of possibilities, right? You could have that function calling back into the database to run an aggregation framework to update a materialized view, right? Append data to the end of a collection, of an existing collection, as part of a dollar merge operation in your aggregation framework. It could be calling back into one of your other services or back into your application to do something else. It could be publishing that data out to a queue, for other services who want to subscribe to that topic to do things with that information from that point. So triggers and functions, very popular, very common in modern and cloud architectures specifically. Native visualization is another side of this. So MongoDB Charts is the native visualization tool for MongoDB, and it's implemented and it's right there in Atlas, and it's just included. It comes with it, right? So you can build visualizations and charting, and you can embed those into your applications. You can do it through a user interface, the way a business user might, but you can also do that programmatically and go ahead and, if you want to create a chart of a customer's history or something like that, you can embed that into their application so that they can view that. Then you've also got back-end services like data access and privacy. You might want to call out to a third-party authentication service like Google or Facebook for authentication. That's implemented and straightforward. You might want to have granular field-level entitlements through a back-end service layer. This is very common for platform types of applications where the users on the platform have their own data on the platform, and those users might actually control who they're going to share their data with, right? And this might be social, right, where people are just sharing things because they want to, but I've also worked with a customer who was monetizing this, right? So they were the platform and they had their customers on the platform. Their customers had data assets, research and things like that they were storing on there. And then the platform's customers would offer subscriptions out to other platform customers to share different levels of detail in that data. Right. And so they would actually charge a subscription for it. And then the platform would take some very small, tiny fee on top of that as well. So there's a lot of great stuff with that. We'll see an overview of it. Mobile database is another important point here. RealmDB, the most popular mobile database in the world, is now under the MongoDB umbrella as well. And that has been integrated deeply into MongoDB Atlas and Realm, and offers great services in terms of automatic synchronization. So synchronizing data between your MongoDB environments in Atlas and edge devices, the mobile device of your user, maybe for their account data that needs to be cached, things like that. SDKs, etc. So there's a lot to offer in the platform, and let's go ahead and dig into it. So this should be familiar to us by now, right? We've got this cluster in this particular project, and let's look at how we can just put a watcher or a trigger onto a specific bit of data. So we might add a trigger and we would just say updates to listings would be the name of the trigger. And we're going to link it to our cluster, and we're going to specify this particular database, the Airbnb database, where I've got some Airbnb data with location. And if those listings get updated, I want it to trigger this function. And you see this function is pretty much empty right now. There's a bunch of helper text here to help orient your developers and to help orient yourself around how to just build this function. But this function could be doing a lot of things. It could reach back into the database, as I said. It could reach out to another service. It could publish this to a queue. We could actually include the actual data change itself. So the actual new listing updated that would be included as part of that payload. And we could also just send this out to EventBridge, AWS EventBridge, where other AWS services can pick up on this as well, right? So there it is. We did this based on a trigger, or basically watching this particular collection, but we could have also just had a scheduled function as well. And that would follow just a normal cron schedule. And it has an interface for setting it up, or you can just use, good old fashioned cron schedule expressions as well. So that covers triggers. And next, let's go into charts, the visualization, native visualization that just is right here in Atlas. So what you do with charts is you add data sources. So we specify which data sources. We've added some data sources here. It's easy to do so. We say it's going to be from this cluster, and we say which data we're basically going to be adding. So we just specify which databases and which collections we're going to add as data sources to it. Secondly, we're going to add and create dashboards. So let's create dashboard 5 here, maybe 6. And then we're going to go ahead and add charts to this dashboard next. So we add a chart, and we'll select a data source. You'll see the green highlights are really to help point you to where you have a required task that you'll have to go into. So let's go ahead and look at movies, right? And what you can see is right away, charts actually understands MongoDB data right away. So it knows that this is an array field, right? And we might be dragging this to this x-axis, and then it's going to ask for us to choose a method, and we might be unwinding the array. You'll notice this is a visual way of building aggregations, right, for MongoDB that are appropriate for the particular visualization that we're choosing. So let's actually build one that makes sense. Maybe a line chart, and maybe we're going to do it on some numeric data like runtime on the x-axis, and let's look at the Metacritic score on the y-axis. And there you go. Right away, we've got a pretty great insight, which is that if the movie is around 90 minutes, they get the highest score, and it drops off very quickly in either direction, longer than that or shorter than that. So we can save this chart, and there it is. It shows up in our dashboard, and we can kind of customize how it shows up on the dashboard and in what order these show up on the dashboard. We could do another chart here from the same collection. Let's do one that is a column chart, and it's title on the x-axis, and let's look at awards that they've received. So nominations, and let's also do wins. How many did they actually win, right? It's already prompting us for what kinds of aggregation methods we should be using that make sense for this type of chart, etc. Right? And what we see is obviously there are too many titles for this type of graph to really make a lot of sense. It is ordered though, so that helps. We're seeing the top ones, and so we could always limit this, but maybe we just want to add a filter as well. We can put a filter, and maybe there are only specific titles that we're interested in. Blind, Broken, Darling, Frozen, Home, and Love. How about? So there you go. Now we have a chart that looks good, and it shows us titles that we're interested in, and it shows how many awards they won. And now we've got it on our dashboard. We can also govern the access to this dashboard appropriately as well. So there you go. Charts native visualization allows you to build visualizations. You can do it programmatically or through a user interface. It integrates directly. It speaks Mongo's language. Really great value there. Next, let's look at Atlas Search. So Atlas Search is very different from just database technology, right? Search deals with specialized indexes for providing rich contextual search capabilities. It gives you things like fuzzy search, autocomplete, filters and facets. Highlighting is returning not just the data you queried for, but the context around that. Custom scoring, you can boost certain parameters. You can query on, there's multi-language support, there's multi-data type support as well. And it's fully integrated into the aggregation framework. So this is kind of pseudocode, but it's just to illustrate how rich the search you can kind of build with this. You simply have a normal aggregation pipeline. You're going to use the $search operator. And then this is a compound search where we're getting all of those wonderful features of Lucene. It should contain these terms. It should be near 1,200 square feet. It must contain the phrase dog friendly. It must be near San Francisco, etc. We can also have, we can filter based on specific ranges of price or geolocation as well. So this is pseudocode, but I do have a version of this kind of query in actual aggregation framework, and this is what it looks like. Very intuitive. It's well documented how you do this stuff. So here we're performing that search against the search index, the specialized Lucene search index. We're projecting out only the fields that we want to see, the description, the price, and the score. We're then sorting in ascending order based on that score, and we're limiting our results to 10 so that we can page it. So there it is. We're running against the database and running those commands right there. I guess I've been disconnected from waiting for too long. But you get the idea. How was that index created? It's very straightforward. We go to collections. We go to Airbnb. We go to our listings and reviews. We go to search indexes and we create that search index. And then we can specify all kinds of specialized index definitions in here that are well documented as well for how you would like this index to behave. So very exciting stuff there. And finally, let's talk about Data Lake. Data Lake provides a foundation of your actual Atlas data, your operational high performance data, as well as data that you have in what we call an Atlas data lake. So this would be file-based. You would take records from your MongoDB data and put it into an S3 bucket, and there it would sit, and you can go ahead and run Mongo queries against it. You also have Atlas Online Archive, which does that automatically. So you would just specify, hey, once the data is older than 3 years old, Atlas, please archive it to this fully managed data lake, and then I still want to be able to query it. You can set these up as federated so that you have a federated endpoint to query your database and also your data lake. You don't have to handle the logic in your application side to figure out, wait, has this data been archived yet or not? You just run the query against the endpoint and you get the data back. Fantastic stuff with data lake and very easy to use. Here it is. There's one that's set up. You're basically going to configure it for basically the S3 bucket that you're going to go against. And we've got one set up here and it has a connection string. So, we use the connection string. We go over here to our terminal. We plug in that connection string, which includes our credentials. I'm using an older version of the shell, so I actually have to tweak that a little bit. I provide my password. And there we have what looks and feels like just a normal shell on a MongoDB environment. So show DBs. Use Airbnb. Show collections. db.listings.findOne. There's one record. So we can issue queries against the data lake and we can see those results. And it's just like normal MongoDB. We can run aggregations against it. And like I said, we can federate this endpoint to span the data lake and your MongoDB operational cluster. And that about wraps us up. To summarize, each of the team members walked us through a different component of MongoDB Atlas in an instructional and demonstrative format. And we got a great overview of the overall MongoDB cloud platform. A special thanks out to each of today's session speakers and a personal thanks to you. I'm Aaron Ballister, reminding you to attend the other great sessions as part of today's conference. And on behalf of all of us at MongoDB, we encourage you to continue thinking big and going far.